Okay, so let's start with the next segment of stoichiometry, which is empirical formula and molecular formula. So in this segment, we'll be going over specifically how to calculate the empirical formula and molecular formula because questions regarding this particular concept are repeated very frequently in the past papers. Okay, so you have to be really good at it. So this is the unit content. We'll be covering this over the next 2 and 3 weeks. इसकी बहुत ज़्यादा extensive practices required. तभी आप लोग जाकर you can do it because most of your O levels chemistry paper and even A levels chemistry paper consists of molar calculations. So if you're good at them, that means like you have covered 40%, 40 to 50% of the chemistry. So let's define molecular formula. So the molecular formula is the actual number of atoms in a molecule, and it has a relationship to empirical formula. Uh, so for example, if you have like a molecule of glucose, so the molecular formula will tell you how many of each type of atoms exist in that molecule, right? So, for example, glucose has a molecular formula of C6H12O6, right? That means glucose has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms in its molecule, right? This is the molecular formula. And similarly, if I write the molecular formula of, let's say ethanol is the alcohol, right? And the common rubbing alcohol. So the molecular formula for ethanol would be C2H5OH, right? And this is not the molecular formula, it's actually the displayed formula. So the molecular formula would be C2H6O, right? So this is the molecular formula for ethanol, right? And this tells you how many of each type of atoms are in this molecule, right? So molecular formula is pretty simple, right? So let's move on to the empirical formula, and then I'll describe the relationship between empirical formula and molecular formula. So empirical formula is the simplest ratio of atoms in a compound, right? So if you have a common divisor for the number of atoms, you just cancel out those numbers, and the simplest ratio of atoms that you get in that compound is known as the empirical formula. So let's just take the old example of glucose, right? We'll be using this example a lot to understand empirical formulas and molecular formula. So C6H12O6, right? So the number of carbon atoms in this molecule of glucose are 6, right? The number of hydrogen atoms in this molecule of glucose are 12, and the number of oxygen atoms in this molecule of glucose are 6 again, right? This is like the ratio of the atoms, right? So if you want to calculate the empirical formula, you will just divide it by the common divisor, right? The common divisor of the all of these numbers. So here, in this case, it is 6, right? So 6 and 6 into 2 is 12, and 6, 1 is 6 again. So the empirical formula for glucose would be CH2O. So yeah, simple. Okay, this is the difference between molecular formula and empirical formula, right? So basically, if you know the molar mass of that compound, right? And if you know the molar mass of the empirical formula. So if you know the mass of the molecular formula, and the mass of this molecular formula, and if you know the mass of this empirical formula, so you can actually calculate the other formula, right? So for example, if you're given with the empirical formula and you know that the actual molecule weighs this much, so you can calculate the molecular formula from the empirical formula, and we will be going over this in the next segment of our video.